In this video, we're going to talk about multiplying and dividing rational expressions. Rational expressions are really just fractions, and these fractions that we're working with today are going to have some variables along with. So to get started, before we get to the multiplying and dividing, we're going to start with just simplifying fractions. So before I talk about how we're going to do that, let me just give you an example with numbers. So let's say we had 6/10, right? We know that there are some common factors here, so that this is not really the reduced form of this fraction, right? 6 is 2 times 3, or 10 is 2 times 5. Since they both have a 2, right? 2 divided by 2 is 1. So really, if we were to reduce it all the way, 3/5 would be the better representation. Right? This is the process we're going to start with. We're not going to just be using numbers. We're going to have some variables involved. So we're going to use factoring to break up both the numerator and the denominator, just like we did here. And then we're going to reduce the fraction. We're going to cancel out anything, 1 for 1 in the top and the bottom. And then we're going to write it in lowest terms, just like we did here. All right, so let's try this one. We have 9x minus 3 over 27x minus 9. All right, this type of factoring, I think, kind of throws people off sometimes, but don't forget about the GCF, right? And that's what we're working with here. So in the numerator, what's the GCF? Should be a 3. If we divide by 3, we'll have 3x minus 1 left over. In the denominator, what's our GCF? Should be a 9. We'll have another 3x minus 1 left over. Okay, all these are multiplied. So anything we have in common, 1 in the top and 1 in the bottom, we can cancel them out because they divide by each other to get 1. That's going to leave 3 over 9. But we can even reduce this, right? 9 is 3 times 3. And so our final answer would be 1/3. I think you're going to like this section. There's a lot of canceling involved and it's very satisfying. All right, let's try a couple more of these before we go on, and we'll add in the multiplying and dividing. How about this one's from your book? So if I factor the numerator, looks like I have a GCF here as well. X, and then I can factor the denominator. This one is not a GCF, so I'll make my 2 parentheses. I need 2 numbers that multiply to be 2 and add to be 3. Okay, and then like we said, we can cancel. So I have an x plus 2 in the top, and then I have an x plus 2 in the bottom. So I can cancel those out. And I get x over x plus 1. All right, the next question that's probably good to ask now before we get thick into it is, can I cancel these x's? It's very tempting after we start canceling just to start striking things out, but there are times when it's okay and times when it's not okay. It's okay if the pieces are multiplied, right? Here I have x times this x plus 2. Here I have x plus 1 times x plus 2. I can cancel. But when I don't, these are not multiplied, right? If I have addition or subtraction, I can cancel with just pieces of it. So it would not be appropriate to continue after this. This is as far as we can go. All right, how about this one? Let's start with the denominator. If I factor the denominator, what will I have? I think it should give us an x plus 3 and an x minus 1. All right. For a lot of reasons, I want to show you a few things. I'm going to leave the numerator the way it is and try to factor it backwards like this. I know it looks weird, but I really want to show you this. This is not your only option by far, but we're going to try this out anyway. Now the x's are in the back. I need two numbers that multiply to be 5 and add to be -4. Okay, and I want a -5x, and I want a +1x to add to that -4. All right, so then the question is, and this is why I picked this example, are these the same? Can I factor them out? Right now they are not the same, right? Why? 2 minus 3 and 3 minus 2. Right, if I reverse the order, 3 minus 2, I know that's 1. 2 minus 3 is -1. Right, so if I can't reverse the order around subtraction. I can reverse it around addition. Right, 5 plus x, that's the same as x plus 5. That's not a problem, right? There's a property for that. Okay, if I want to flip it around subtraction, I'm going to get an extra negative. So if I do it, I have to factor out that negative. Oops. If I factor out a -1, then I can go ahead and flip it around. All right, let me just make a side note. Continue my side note. Okay, let's check it. I don't want you to take my word for it. I want you to believe me, so let's check it. If I multiply by -1, I'm going to have -x plus 1. And we just said we can flip it around a plus. So I can put the 1 in the front. If I have a plus, this would be plus -x, which is the same as 1 minus x. Right, so I can reverse these as long as I add an extra -1 on the outside. Now we can cancel. And I'm going to put this -1 in the front because that's where we're used to seeing it. And that's going to give us our final answer, right? And you can leave the final answer in factored form. You don't have to re-multiply it out. We're not trying to do extra work here, right? So it's fine to leave it like that. All right, so this is simplifying, right? Really, this is the main idea. We're going to add a few details with the multiplying and dividing, but overall, this is still our main strategy that we're going to be practicing. So to multiply fractions, I'm still going to factor everything. Then I'm going to combine. When I multiply fractions, I multiply the numerators and I multiply the denominators together, right? So if I had 2/3 times 4/5, okay, to multiply them, I multiply the tops, 2 times 4, and I multiply the bottoms, 3 times 5, right? So I'm going to do both of those. And then from there, I'm going to reduce, right? So I'm not going to FOIL it back together at this step. I'm just going to kind of write them all together in one line. All right, so let's try this one. First, we need to factor everything. So if I factor the top of the first fraction, I need two numbers that multiply to be 35 and subtract to be 2. And 7 and 5 are going to work. I want a -7 and a +5. All right, for the top of the second fraction, this is a GCF, x squared. For the bottom of the first fraction, also a GCF, x squared. And then the bottom of the second fraction, also a GCF, this time of 2. Okay, I'm usually really lazy about these. So technically all these things in the top are multiplied together. You could rewrite it down here if you like. All right, or you could be really lazy like me and just like take this fraction bar line and draw it straight across. Voila, now they're all combined into one fraction. All right, so what can we cancel? 1 for 1, right? So x minus 7, x minus 7, x squared, and x squared. I think that's it. So our final answer will be what's left. We have x plus 5 times x minus 1 over, we still have a 2 here, 2 times 2x minus 3. And again, we're not going to FOIL these back out. Could you? Yes, but do you want to? No, not really. Okay, so just leave it just like that. It's totally fine. All right, that's multiplying. Right? It's pretty much the same, but we did, multiply all the tops together, multiply all the bottoms together. All right, how about dividing? Dividing, we're going to factor everything, just like we did in all the other examples. To divide fractions, I do keep, change, flip, right? I keep the first fraction, I change it to multiplying, and I flip over the second fraction. So when I do the flip, really I'm multiplying by that reciprocal, right? So let me give you an example. Like, I'm just making something up, okay? 1/10 divided by 1/2. I'm going to keep the first fraction. I'm going to change this to multiplying, and I'm going to flip over the second fraction. All right, then now I'm multiplying. So just like we did before, I'm going to multiply the tops, 1 times 2. I'm going to multiply the bottoms, 10 times 1. So I get 2/10. But I can reduce, right? So then I start to cancel some things out, and I get 1/5. That's the basic idea. We're just going to put in a whole bunch of variables. Okay, so let's do that. I personally like to do the keep, change, flip part before I start factoring so that I don't get it mixed up. So I'm going to do it like that here as well. Okay, so I'll have x squared plus x over 2x plus 6. So I'll keep. I'm going to change it to multiplying. And I'm going to flip this one over. So now I have x plus 3 over x. All right, so now I'm going to factor everything I can. If I factor the top of the first fraction, I have a GCF of x. If I factor the bottom of the first fraction, I have a GCF of 2. And I really can't factor anything in the second fraction this time. Okay, here we go. I'm going to be lazy again. We're multiplying, so we're just going to connect the dots here. Everything in the top is now multiplied. You can put parentheses if you want. Everything at the bottom is now multiplied. So I can cancel 1 for 1, x plus 3 and x plus 3, x and x. So my final answer will be x plus 1 over 2. All right. I think I have one more for us to try. I'm resisting the urge to ask if you have any questions. Because I can't do that anymore. All right, so again, I'm going to start with the keep, change, flip on this one as well. So I'm going to keep the first fraction the same. I'm going to change it to multiplying. And I'm going to flip over the second fraction. So what was in the bottom, I'm putting in the top. What was in the top, I'm putting in the bottom. I know this one looks kind of massive compared to some of the others that we've done, but it won't really be challenging if we can do all the factoring. That's really the hardest part. Okay, now notice for all of these we have factored, right? At no point have we taken these and FOILed them together. Like that would be some ginormously huge x to the fourth something, 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 right? On the test, people get desperate and they do those sort of thing. Don't do that, right? We're simplifying here and we're using factoring to help us do that. If you leave out the factoring part, it feels impossible. Okay, so if I factor the top of the first fraction, I think 2 and 1 are going to work, and I want them both to be negative, so I can get negative 3. In the bottom of the first fraction, this is the tricky one because 2 and 3 is what we want, right? 6 and 1 won't work because of the signs, right? So 2 and 3 is what we want. It's a positive 5, so we want both pluses. Okay, for the second fraction, we want 3 and 1. This is a positive 2, so I want positive 3 and negative 1. In the bottom of the second fraction, I need 2 and 1. And this is a positive 1 in the middle, so I want the 2 to be positive and the 1 to be negative. All right, just like the others, I'm multiplying here, so now all the tops are now going to be in the top of one big fraction. All the bottoms are in the bottom of one big fraction. Remember, I can cancel 1 for 1. So what can I cancel? I can cancel 1x minus 1 with 1x minus 1. I can cancel 1x plus 3 and 1x plus 3. I can't cancel the 2's because this is a minus and this is a plus, right? And these are both in the bottom. I can't cancel them. I have to have one in the top and one in the bottom. All right, so that's all we can do. So our final answer, x minus 1 times x minus 2 over x plus 2 times x plus 2. If you want to write this as x plus 2 squared, you could definitely do that. That's optional, right? You can, be great. If not, this is fine. Again, I'm not FOILing these out, right? I'm just leaving it factored as my final answer. All right, well, I hope I gave you a good idea of how to kind of manipulate these fractions with multiplying and dividing and simplifying. This is going to take some practice. Hopefully it'll kind of bring in some of your factoring skills again. So good luck.